All right. What's up, everybody? Are we ready for some calculus review? Let's go. We're talking about related rates today. Okay. Between 0 and 6 seconds, a screensaver on a computer screen shows a circle that starts as a dot and expands outward. So cool. I'm going to draw a circle. Here we go. At the instant that the circle has a radius of 9 centimeters, the radius is increasing. Now remember, you're going to write down all your things as you go. So when I saw a radius of 9 centimeters, I'm going to either label my picture or I can put it out here. The radius is increasing at a rate of, that's dr dt, 3/2. I'll just include my units at the end. Okay, find. So whenever you see the word find, we want to pay attention because that's what we're looking for. The rate at which the area of the circle is changing at that instant. So I'm looking for dA dt, okay? So I need to figure out an equation that will allow me to relate A and R, and we know that equation is area of a circle. So if area is pi r squared, the derivative of that is pi, derivative of r squared, so the pi stays in front because it's a constant. Derivative of r squared is 2r dr dt. And then I can just start plugging my stuff in. So it's going to be pi 2 times 9, because it's at the insert when the radius is 9. Dr dt is 3/2. Okay? I'm pretty sure this is mostly going to be no calculator questions. So, I mean, just don't put your answers as decimals or anything, but you can reduce and do things like that. So, this is going to be 27 pi. Now I'm ready to do my units of measure. Okay, this was, well, actually I should keep this here. This was in centimeters because it's area. I'm doing centimeters squared per time. I just have to see what the time is. It's per second. Okay. All right, so that's all for part A. Okay, so now let's go ahead and look at part B. Move this over so I have enough room. Okay, and for part B, it says the radius of the circle is modeled by this equation. Negative 0.5t for time between 0 and 6. When you start seeing equations that aren't what we're used to, in fact, like, I mean, we're used to area, we're used to volume, we're used to stuff like that, but they just throw something random at you. Guys, it's the related rates test. You're going to take a derivative, okay? So don't let it stress you out. And W of t is the radius. So basically, they're using this instead of R. It's the same thing, though. What time is the radius of the circle increasing at a rate of 3 centimeters per second? So what is it asking me for? At what time? Okay, so it would like me to find t, and then it's telling me, is the radius increasing at a rate of 3 centimeters per second? That is going to be dr dt is going to be positive 3. All right. Now, if it's bugging you that it's W, just change it to an R or change that to a W. I think it's weird that they switched variables. So I'm just going to say, oops, that the radius is that. Okay. So now I'm going to take the derivative with respect to time. All right. So dr dt, 12 is a constant. That's going to go away. Negative 12 is a constant attached to the e, so that'll stay in front. And then the derivative of e, you guys remember, is e to the negative 0.5t times the derivative of the exponent because of chain rule. The derivative of the exponent is negative 0.5. Now, you might be wondering, move this stuff out of the way, why we didn't have to put anything over here in terms of like a d something dt. Well, look, this side, the only variable in it is t. So dt dt, we don't need a dt dt. There weren't any other variables. So you just have to do it when it's a variable different than time. Okay? So now that I've got that information, dr dt is 3. And that's negative 0.5t times negative 0.5. So do I have enough information to solve this? Hopefully. Okay. I'm going to combine those together first, I think. Now, I know a negative times a negative is a positive, and I know 12 times 0.5 is 6. All right. I divide both sides by 6. I get 1/2. Okay. In order to get rid of the ln, I should give myself a little bit more room. All right. Sorry, in order to get rid of the e, I need to then take ln of both sides. So this says the ln of 1/2 is negative 0.5t. And then I just have to divide both sides by negative 0.5. If this was a no calculator test, okay, and if we have a question like this, I'll let you guys use a calculator, but if it was no calculator, you just leave it like that, okay? ln of 1/2 divided by negative 0.05. Since I have a calculator though, I'll go ahead and do that. Divided by negative 0.5. Okay, cool, and I get 1.386. We need units for this. Now, t that we just solved for is time, and time everywhere we're talking about here is seconds. So it's 1.386 seconds. All right. Okay, cool. Let's go ahead and look at number 2. We got this kind of funky balloon over here. The balloon shown is in the shape of a cylinder with hemispherical ends of the same radius as that of the cylinder. So basically, you guys, I have a sphere up here. Down here, I have half up there, half down there, and I've got the cylinder. So like we can call that R or whatever. All right, the balloon is being inflated at a rate of blah, blah, blah. So what does that mean? Well, it means I'm blowing it up. So that's dV dt. One of the reasons that I can tell its volume is because cubic centimeters, we know volume is something to the third, and then per minute tells me it's the dt. Okay, so that's 261 pi. Again, right now I'm just going to use numbers. I'll like label it at the end. Okay, at the instant, the radius of the cylinder is 3. Radius is 3. The volume of the balloon, so the volume is 144 pi cubic centimeters. So it's not per anything, it's just the volume. And the radius is increasing at the rate of 2 centimeters per minute. So dr dt is 2. Whew. Okay. At that instant, what is the height of the cylinder? Crazy. Okay, so it's basically pretty straightforward, except for the fact that I've got these 2 separate volumes. Well, you guys see that I have basically one cylinder here, and between that and that all together, I have one sphere. So the volume of this entire balloon, I'm gonna just go volume of my balloon or whatever, the whole thing, is the cylinder plus the sphere. Okay, so it's like one cylinder, one sphere. At this instant, what is the height? Okay, what is this one asking me for? It's asking me to find h. Alrighty. Let's take a derivative here. So dV dt is pi. Oh my goodness, I got to do a product rule on this. Okay. Okay, I think I'm gonna get more room. All right. For my product rule, you guys, I'm gonna go derivative of the first times the second plus the first times derivative of the second. Now that's just the product rule for the first part, and I kept the pi outside, okay? Now for this one, I'm gonna go ahead and keep the 4/3 pi outside, and then the derivative here is 3r squared dr dt. All right? So, no big deal, right? I got all sorts of variables over here. So I'm gonna start plugging things in. Oh, and that, I forgot about that, boom. Okay, dv dt is 261 pi. All right, in here I have 2 times 3 times dr dt times h, which I do not know. We are going to come back to that in one quick second. I have r squared and dh dt, which I also do not know. Okay, now over here I've got, actually I'll go ahead and cancel my 3's out. I think that'll be better. Boom, boom. Okay, so let's go ahead and say I've got 4 pi, r is 3 squared, and then dr dt, which is 2. Okay, so you guys know whenever we have missing stuff, we kind of go back to the beginning, back to like what we have in the very beginning, okay? Let me go back to, when I say the beginning, I mean like before we took the derivative and stuff. I'm going to go back to this right here, all right? And let me see what's going on with the balloon at this, like at this exact moment where all these different things are happening, okay? So if I go back to volume, let me put this over here. The volume is 144 pi. R is 3. That's h. And then I have 4/3 pi, and r is 3 to the third. Okay, so let's focus on this for just a second. 3 squared is 9. I'm going to write that in front if you don't mind. So I'm going to go 9 pi h. And then right here, okay, 3 to the third is 27. And 3 goes into 27 9 times. So are we cool if I just make this 4 times 9, 36 pi? Okay. Move this down a bit so we can see what's going on. Now, I only have one variable in here, and that's h. So I can definitely solve for h, right? And the way I'm going to do that is I'm going to go ahead and subtract the 36 pi over. Boom. Okay, that gives me 108 is 9 pi h. I'm going to go ahead and divide both sides by 9 pi. And I can figure out what h was. H was, I think 108 divided by 9 is 12. So I can go back and answer part A just from that. So maybe I should have done that first, but whatever. Okay, so H is 12 centimeters. All right. Okay, now let's go back over to here. H is 12. So are we good if I go ahead and replace that with 12? Now, the only variable I'm missing in this whole dang thing is dH dt, and that's exactly what I'm looking for in part B. How fast is the height changing? dH dt. So now I got to solve this monster. Okay, it's really not that bad. Let's see here. I mean, I say that, but I don't really know what's happening yet. All right, I'm going to go this way. Okay, 2 times 2 is 4 times 3 is 12. 12 times 12 is 144 plus 9 dH dt. Okay, 3 squared is 9 times 4. No, let's go 4 times 2 is 8 times 9 is 72. Ugh, math is hard. Okay, cool, right? So remember that we're just trying to get into dH dt, so I'm going to take this apart one step at a time. I am going to minus 72 pi from both sides. So I get, dang, 189, I think. I mean, shoot. I'm giving up and I'm using my calculator for a sec. All right. 189 pi equals pi times, in parentheses, 144 plus 9 dH dt. The next thing I will do is I'll divide both sides by pi. That'll get rid of that and that. So I got 189 equals 144 plus 9 dH dt. I will subtract the 144. Ooh, can we do this? 5, 4, 0. 45 equals 9 dH dt. Divide both sides by 9. dH dt is 5. Whoo, that was crazy, but I loved it. All right, dH dt is 5. What are my units? Well, my height is in centimeters per, and my time is in minutes. 5 centimeters per minute. Okay? That was pretty insane, but I liked it. All right, let's move along here. Let's do number 3. Okay, a sculptor uses a constant volume of modeling clay to form a cylinder with a large height and a small radius. Okay. I'd say that's a pretty large height and a pretty small radius. The clay is molded in such a way that the height increases as the radius decreases. Okay, so dH dt is positive, dr dt is negative, but it still retains its cylindrical shape. So the smaller it gets, the bigger. It's like, you know, I'm stretching out my clay or something like that. Okay, at time t equals c, the height of the clay is 8 inches. So height is 8. The radius is 3. And the radius is decreasing at a rate of 1/2. That's dr dt because it's a rate. At time c, so if it says time c, it just means like whatever time, like it's at whatever seconds, I don't know. At time c, at what rate is the area of the circular cross-section decreasing? Okay, what the heck is a circular cross-section? Well, because it's area, you guys, I'm obviously not talking about volume, but the area of a circular cross-section would be like, let's say I take something circular. How do I not have a can of Diet Coke on my desk? All right, fine. I'm going to take this pumpkin roll that somebody gave me. Okay, I take something circular and I slice it in half. And then I look at what I sliced. What shape is the thing I sliced in? So let's say that I were to slice this like that. And then I were looking at the top. What shape is that? That's a circle, okay? So that's all it means is circular cross-section, but I mean, it said circle anyway, so we're kind of chilling with that. So the area of that circle right there, though, it has nothing to do with the height, okay? It's just pi r squared. And we want to know what rate the area is decreasing with respect to time. So dA dt is, okay, the derivative of r squared is 2r dr dt. 2, the radius was 3, and dr dt was -1/2. Don't get stressed out if, especially on part A, something is particularly easy. Part A is supposed to be, I mean, I'm not saying like any of this is easy, but you guys know what I mean. Don't overthink part A. It's supposed to be relatively straightforward. I'm going to go ahead and cancel out those 2's. So I have pi 3 -1. So I'll go and write my answer right here. dA dt is -3 pi. I'll go ahead and do my units. Inches squared per minute because it's area. So that was part A. All right. At that same time, time t equals c, at what rate is the height increasing with respect to time? So what am I looking for right there? What rate is the height increasing? dH dt, because it's a rate. Show the computations that lead to your answer. Indicate units measure. The volume of a cylinder is volume equals pi r squared h. Whoops, that's supposed to say squared. Anyways, yeah, so change that to a squared. So it's pi r squared h. All right, so my volume is pi r squared h. So dV dt is pi, and then I'm going to do a product rule, which is going to go the derivative of the first, 2r dr dt times the second, h, and then the first dH dt, okay? And I'm going to start plugging stuff in. Okay, at time t equals, so you can do it. We're looking for dH dt. Let me just looking for that. Show the computation, indicate user measure, volume, blah, blah, blah. Okay, so I also don't have dVdt, so that's bizarre, but let's just go ahead, go with it. Okay, I have 2r. R was 3. dr dt is -1/2. Oh, and then h, which was 8, plus r squared dh dt. So I'm missing two different things. Since it's asking me for dh dt, at what time is the rate of the height increasing with respect to time? Show the computations. Okay, I should be able to find dv dt. For a quick second, I was stumped, all right? Now, I'm going to go through my process with you, okay? I paused this really quickly because I was like, and I didn't want to look like an idiot in front of my video audience, right? Except that you guys, I only had it paused for like a few seconds. You can trust me on that. Okay, now, I thought to myself, I have a dH/dt and a dV/dt. I got two different things. This is no good. What am I supposed to do? So pause my video. Don't want to look bad in front of my students. And I start reading. All right. And I just start reading again. Check it out. A sculptor uses a constant volume of molding clay. And then I was like, wait, hold on. As I'm like stretching it all over, I'm not adding more clay. I'm not taking away clay. I'm stretching the crap out of it, right? A constant volume. A constant volume. So right over here, what is dV/dt, my friends? dV/dt is 0 because volume is constant. Okay? So, that took me a minute. I was a little bit worried for a second there, but never fear. We're back. That was tough. Okay. Pi. All right. Let's see here. That two are going to cancel out. 3 times -1 times 8, that's -24 plus 9 dH dt. I mean, this is weird, but just to get it out of there, I'll go ahead and divide by pi because 0 divided by pi is still 0. So 0 is -24 plus 9 dH dt. Add the 24 over and divide by 9. So dH dt is 24 over 9, which I can go ahead and reduce that by 3. Again, you don't have to. It's free response, but whatever. I'm going to be a responsible citizen and reduce my fractions. Okay, so for dH dt, I got divide by 3, 8 over 3. The height is in terms of inches per minute. Let's go. All right. Didn't box this. Box our answers. Okay. Write an expression. For the rate of change of the radius with respect to the height in terms of h and r. Okay, let's see if we can figure this out. Actually, let me move this a little. Make this a little smaller. It did not leave myself enough room here. Okay. All right, you guys, part C, super tricky. This is what happens. I tell you guys that part C is always where the mess begins. Let me kind of move this stuff over here for a second. All right. Here's what's tricky about part C. Write an expression for the rate of change of the radius. So rate of change we know is d, radius. Now this is the important part. With respect to height. The rate of change of the radius with respect to height. I'm not respecting time anymore, am I? I'm respecting height. So I actually have to find dr dh. What is that? Haven't seen that anywhere over here before. Okay. Well, dr dh just means take the derivative with respect to h instead of with respect to time. All right. So I have to do it with a dh. Okay. So I need an equation that relates R and H. And I got one right here. Okay, so let's go with part C. Now, if my volume is pi r squared h, I'm going to take the derivative with respect to h. So instead of putting everything dt, you want to put everything dh. All right, check it out. dv dh equals pi. Now I do got to do a product rule here. I still got to do a product rule. Okay, because those are both variables. Derivative of the first. The derivative of the first is dr dh times the second. Okay? Plus r squared, and then derivative of the second. Now the derivative of h is 1 dh dh. But since I'm taking the derivative with respect to itself, right, dh dh, don't actually need that. Okay? Okay, now, I'm going to go back one more time because I was thinking that I was going to need to plug in variables or whatever, but actually what it's saying is write an expression for the rate of change of the radius with respect to the height. dr dh, okay? Hang on here, dr dh, in terms of h and r. That means that I want my equation to say something like, okay, dr dh equals blah, blah, blah with an r in it, blah, blah, blah with an h in it. So I need my r and my h. Now, the only thing I don't need is this, dv dt. But just like we talked about before, okay, as I'm stretching the volume out over time, the volume is remaining constant. How about this? As I'm stretching the volume out over height, still a constant, right? The volume is constant, which means up here it's constant, which means it doesn't matter what I take the derivative with respect to, dv d whatever is going to be 0, okay? So I can say that that's 0, and now I can basically, I just want to solve this for dr dh. Oh gosh, all right. Divide the pi over, look, 0 divided by pi is still 0, so I don't need the pi in there basically. Write this a little better. I'm going to write this as 2rh dr dh plus r squared, okay? I'm going to subtract the r squared to the other side. And then I'm going to divide the 2rh over, okay? I'll divide both sides by 2rh. Let me make this smaller so you guys can see. I was trying to save paper. Clearly, I need to go make your copies so that you have much more room. Okay, all right, so here we go. That crosses out. dr dh is... Now I can actually cross out one of these r's, negative r over 2h. That is the expression for dr dh in terms of r and h. That was tough. That was tough, all right? Negative r over 2h. Remember how we've kind of been talking about like the c portion of these is kind of like what, you know, separates like 4s from 5s. And you guys are awesome. You keep putting in the same amount of work you've been putting in, you guys are going to get 5s because you're doing great. But it's all about like reading the questions and really like understanding like what it's asking you for. You know what I mean? Okay. That was enough of that. Let me stop this video and we'll start a new one.